Today we're going to talk about how to find the domain of a function. So if we have f of x equals to 2x minus 7, this is basically a linear function. The domain here is going to be all real numbers. That's negative infinity to infinity. Another example is f of x equals to x squared plus 3x minus 5. This is a quadratic function and its domain is still going to be negative infinity to infinity. As well as polynomial function. Their domains are from negative infinity to infinity, all real numbers. So, in case of linear functions, quadratic functions, and polynomial function, the domain is all real numbers. They are varied from negative infinity to infinity. But in rational functions, cases are different. So here, we're going to set the denominator equal to 0. So it should not be equal to 0 because it's going to be undefined. So if we solve for x here, that is going to be our critical number and we're going to put in our number line. So here, it's negative infinity and infinity. Now we're just going to read from left to right. Look for left to right. That's negative infinity to 2, union 2 to infinity. So this is the domain of this rational function. Now, let's try this one. So again, we're just going to set the denominator into 0. So x squared minus 9x plus 20 is equal to 0. And what we can do here is just basically factor this out. So we're going to multiply it to the coefficient of the first. So we get this. So the factor of x squared minus 9x plus 20 is x minus 5, quantity x minus 4. So if we're going to solve for x here, we get our critical numbers as 5 and 4. There you have it. So now we're just going to look from left to right here. So the domain of this rational function is negative infinity to 4, union 4 to 5, and union 5 to infinity. Oh, what's happening here? So 5 to infinity. So this is the domain of this rational function without a quadratic function in the denominator. Now how about this one? 2x minus 3 divided by x squared plus 4 equal. We're going to set the denominator to 0, and as we can see here, we're going to take the square root of both equation. We got a imaginary number, so that's why we're just going to put negative infinity to infinity. Now, what if we have a radical function? So to find the domain, we're just going to set the numerator greater than or equal to 0 and solve for x, and then we're going to plug in the value of x that we have solved. So we already know how to plot this in the number line, and that's going from 4 to infinity here. So the domain is, we're going to put a bracket instead of parentheses because we have a closed circle. So this is it. So let's try this one. So again, we're just going to set the numerator greater than or equal to 0. So in this case, we're going to factor out the quadratic function. So factor of this is 7 and 4. We're going to put a negative into 4. So we got x plus 7, quantity x minus 4. It's greater than or equal to 0. Now we have this critical numbers. We're going to plug it into our number line. So solving for x, we got 4 and negative 7. And we're going to put open circle. Closed circle. Now we're just going to plug in points which is greater than 4. So if we plug in points that is greater than 4 and plug into x, we get a positive on that region. Now, let's pick number between -7 and 4. Let's pick 0 and B have a negative. Now, let's pick a number that is less than -7. So, let's pick -8. So, if we plug in -8 to our equation, this will give us negative, and we have negative, and we multiply it, so we get positive. So, we have positive region here. So, in our case, it is greater than or equal to 0, meaning that we're just going to shade from the positive region. So we got 4 to infinity and negative infinity and -7. So our domain here is going to be negative infinity, comma -7, and we have a bracket, union bracket 4 to infinity. So this is the domain for this radical function. Now, what if we have a rational function and a radical function? So we're going to set the denominator greater than 0 instead of greater than or equal to 0. So this is just the same as earlier. We get -3 here, we get an infinity and negative infinity. We're going to put a nice open circle, and so the domain here is basically -3 to infinity. So that's easy it is. Now let's try this one. So first, let's set the numerator greater than or equal to 0. So got x is greater than or equal to 4. Forgot the equal sign on the here. And then we're going to find the critical numbers on the denominator. So that x plus 5, quantity x plus 5. Now we have our critical numbers. Let's just plug it into our number line. So we got +5, -5, and +4. Oops, we did put 0. We did 5 here. We got 4 and -5. We have a negative infinity and infinity. Okay, now we have a closed circle, open circle, and open circle. So I'm going to shade it. That's going to be here. So the domain, we're going to include 5 here. So we got 4. We should be using bracket. So it's 4 to 5, union 5 to infinity. So this is the domain for this one. Now, how about this one? This function. So we have a rational function and a radical function on the both numerator and denominator. So again, we're going to our method. The first one is set the numerator greater than or equal to 0, and we're going to set the denominator greater than 0. Okay, now, so we do have our critical numbers, which is -3, 4, and -4. Okay, so we have a case, we have greater than or equal to 3 and greater than 0. So we're just going to shades everywhere, but we're going to look for the regions of positive and negative. So we got the positive region here from -4 and infinity and negative. Okay, so now we can just put this is greater than or equal to -3, and also 4 that is greater than 0. We have a positive region here, so there. But in this case, we're not going to include negative infinity to -4. Since we have a negative region here in between -3 and 4, we're not going to include it too. And then we're going to plug in number between -4 and -3. We're not going to include it too. So the only thing that we're going to include is this thing, 4 and infinity. That is where the -3 to infinity and 4 to infinity, they overlap. That's why we're going to choose it. So we got this domain.